Task 12D is here. In this task, we will try to come up with a Boolean method that returns whether a given integer is a prime number or not. But what a prime number exactly is, right? Uh, Turns out that a prime number is the product of two distinct prime numbers, such as 6, like 2 times 3 equals to 6. 2 and 3 are distinct prime numbers, therefore 6 is a prime number in our case. But for example, 4 is not a is prime number because for 2 by 2 equals 4, yeah, but 2 by 2 doesn't it are twos are not distinct prime numbers, they are duplicates, so 4 is not a prime number in our case. uh, to calculate decides to do that, uh, we have two methods in here. One of is the famous is prime. I'm not going to explain that one. In here we have the boolean method called is trime distinct. At first we are checking whether these cases is are they true or false, because we know that any prime number cannot be a prime number, because basically a prime number is a product of the multiplication process, but not, so therefore it's impossible to any prime number to be also be a prime number. So we are getting rid of all these prime numbers in our potential list. We are also getting rid of the numbers that's smaller than 1 and 1 itself, because we know that it's not going to happen simply. uh, and there's also 4 in here because I don't know, but code itself doesn't contain the 4 itself, so I had to hard code it in here. In here we are checking the whether the given based on in this line we are basically checking that all the possible um, even prime numbers. If that's the case, this means that our number is a even prime numbers. So we are directly reaching getting the part of it. We are directly getting returning a true. So we are cutting it right there. If that our number is a even prime number. If our number is a odd number, that's gonna be a take up for that's gonna take a while to come up with the answer. So we are going right here. In here we have this loop. We are integer equals to integer I equals to 3. We will increase the I value by 2 each time, because we know that we already eliminated all the even prime numbers at these lines, so it's meaningless to check them again. So we will only look for the odd numbers. So we will increase the I value by 2 each time the loop iterates. Inside of the loop, at here we have this condition is prime, and is prime num divided by I, and num mod I equals 0, and num not equal I1 I times I. Uh, that's the whole actually the thing that goes on. Uh, we are checking whether sorry, whether the whether the given in number is a odd time distincts. We are checking whether the is there any duplicate, or is it divisible or by I, such things. We are checking them at here, and if that's the case, we will return a true. If that's not, it's just gonna return false. In here we have the example parts. I prepared that for to check. Let me try. 36 is not a prime number. 12 is another prime number because it cannot be written as two different prime numbers. 9 cannot be written, so therefore it's not a prime. 7, it's a prime, so not gonna happen. 4 not a trime. 7 to 7. It should be a trime number. Yeah, it's a trime number.